welcome to day 46 of 50 days of tutelage. We are going to be discussing about statistics today. So before we proceed, let's give a definition to what statistics is. So simply, statistics deals with the collection of numerical data. So the bedrock of statistics is based on numerical data. And on this numerical data, you do a lot of things with it. You, first of all, of course, you collect the data, you organize it, you present it, you analyze it, and you interpret it as well, so that you can draw conclusion and make some informed decision from there. So you collect data and you do a whole lot of things with it, analyzing, deduction, you know, all sort of things that I've listed earlier. You do them on the numerical data that you have collected, and this is basically what statistics is all about. It's all about everything we do on a numerical data. So we first of all do all of those preliminary, we analyze, we make deductions, and from there we're able to decide on something else, maybe some futuristic thing. Okay, based on this thing now, it means that this is where we're going next, and all of those things. So if you look at some of these market predictions, if you look at some of these economic reforms and the likes, it's because they have been able to collect a certain data based on the current economy that they are dealing with and the past as well. So when they bring all of these data, when they bring all of them together and they analyze and they look at what they are doing currently, they can say that, oh, this is where we are headed, and all of those things. It also deals with birth rate, death rate, and all of those things as well. So it varies in different form and all of that. So statistics is a very, very important aspect of life because it helps us keep track of how things are happening and how things can actually happen. So that is basically the idea of statistics. So in statistics, there are so many things that we use. I've mentioned the first major thing, which is the data. So data is the first thing that you collect there. That's basically the figures or the facts that you want to collect for a particular purpose. It could be, like I've given you example already. It could be the birth rate of a particular community and all of that. So after that, the next thing we'll talk about is frequency. So frequency is also another term that is being used under statistics a lot. So what is frequency? Frequency is simply the number of times that something is occurring. So let's say, for instance, you want to talk about uh, different breed of dogs. You want to talk about different breed of dogs. So let's say there's a breed A, there's a breed B, there's a breed C, there's a breed D. So let's say we have these four breeds of dog. So it's possible that in your data collection, you have breed A occur like 10 times, you have breed B occur like 2 times, you have breed C occur like 5 times, and you have this one occur like 3 times. So the frequency of breed A is 10 because the number of times that A find itself the number of times that A appeared in that data is 10. So therefore, the frequency of breed A is 10. That is basically what frequency is all about. The number of times that something occurs. So sometimes when you're collecting data, some information they occur repetitively. And so due to that, we have what we call frequency for them. Then we have what we call class interval. Class interval is when you decide to group something together. So for instance, let's say I'm collecting a numerical data now, and then in numerical data that I'm collecting, I have something of this nature. I have one, I have two, I have three, and I have three again. I have four, 6. Then I have 10. I have 20. I have 21. I have 25. I have 30. It goes on and on like that. So, but here's what I can do. Instead of listing all of these things like this, I can make my data much more sweet and much more presentable by saying, okay, I have this set of numbers that I've collected: 1 to 5, 6 to 10, 11 to 15, 11 to 15, and I can have 16 to 20, and I can have 21 to 25, then I can have 26 to 30. So what I've done here is that I've grouped them into class intervals. So I've kind of classed some of these figures. I've classed them into a group of intervals like that. So these 1 to 5, 6 to 10, and the likes, they are called the class interval. So the next one that looks like it is called class boundary. Class boundary. So the class boundary Basically, what this does is that we remove 0.5 from the first term in the class, and we add 0.5 to the last term in the class. So what is the purpose of this? The purpose of this is a kind of loop, creating a loop. You can see that 1 to 5, they seem like there's a jump from 5 to 6. From 6 to 10, they seem like there's a jump from 10 to 11. But let me remove 0.5 from the first member of the class and add 0.5 to the last member of the class. So this one becomes, permit me to just use 3 of them. So from 1, it becomes 1 minus 0.5, that's 0.5. If you add 0.5 to that, that becomes 5.5. Then this one, if you remove 0.5 from it, 6 minus 0.5 is 5.5. Then if you add 0.5 to that, that will become 10.5. If you remove 0.5 from this, that will be 10.5. Then you go to 15.5. So what you notice here is that there is a loop now. So where this one stops is where this one starts. So they are kind of connected in a way. So this is what basically we do with class boundaries. So generally, we just remove 0.5 from the first term in the class, and then we add 0.5 to the last term in the class. So with this, we get the class boundary. And then next thing is the class size. So to get the class size, what we do is that we just subtract the upper class boundary from the lower class boundary. So in this place now, you have 0.5 here, you have 5.5 here. So you just have 5.5 minus 0.5, and that is going to be 5. So the class boundary, the class size in this place is 5. So that is how you get your class size. And the next one is class mark. Class mark. So this is still for group data. So for class mark, all you have to do is to add the upper class boundary and the lower class boundary. Then divide them by 2. So you get the midpoint. So more like you're saying 0.5 plus 5.5 all divided by 2. So what's 0.5 plus 5.5? That's 6 divided by 2, and that is 3. Even if you do it with a class interval, you get the same thing as well. So this class mark is what we use. So imagine the way I listed all these guys before: 1, 2, 3, 3, 4, 4, 4, 4, 4. So all these individual guys, we can call them X. Like these are the data that you have collected. So the class mark is what kind of represents the same thing that we do for this guy. The class mark is what sort of represents them. So this is just a preliminary. I'm just introducing you to some of the things that we're going to be using to analyze data. So let's go forward now. Of course, you can have different ways to present data. You can have your histogram, you can have your bar chart, you can have your pie chart, you can have frequency polygon, you can have cumulative frequency curve, and all of that. But I'm not going to be going into much depth of that. Basically, the ones that you usually like get confusing is the bar chart and the histogram. So for bar chart, what you have is that you have rectangular bars. They must have equal width, and then there will be gaps between the bars. For histograms, you have such that the bars are drawn on class boundaries so that there's no gap between them. So if you have bar chart now, so sorry about that. So this will be what a bar chart will look like. So a bar chart will look like this. Do not mind my whatever in case they are not of the same width. I'm just trying to like give you example. And for histogram, so the histogram looks maybe somewhat similar. So you have something of this nature. You have this, you have this. So this is what so this is histogram, and this is a bar chart. Of course, here we have the frequency. We have the frequency on the y-axis. So that is basically we have representation of data in that. We have the pie chart as well. So the pie chart, you're just using a circle, and then you have different sector, define different things, and all of that. So let's proceed. Now, I want to go into measure of central tendency now. Measure of central tendency. So measure of central tendency. Now, in measure of central tendency, measure of central tendency. So the things we're going to be considering here, they're going to be mean, median, and mode. So these three are considered when we are talking about measure of central tendencies. So they are single values that represent the center or typical value of a data. So they represent a kind of central kind of thing, and then they represent what typical value of a data will look like. For instance, mean is like average. So if you enter a classroom and then you begin to collect data about the age of everybody in the class, of course they will not have the same age. They will have different ages and all of those things. But when you find the mean of that class, then you can say that I think that class comprises of people around age so. So their mean is kind of representing a typical value in that data. Median as well. So if you go from left to right and you go from right to left and you meet at a point, you can say, okay, I think this class, they are this age group, they are in this age group and all of those things. Then mode as well. At least if you look at the number of persons, so if there are 10 persons in that class and 5 of them, they fall in the particular age range, then you can easily conclude that this age is actually what is prevalent in this class. So their measure of central tendency, they give the typical value of what the data of a set will be like. So that's basically what central tendency looks like. So we have for grouped and for ungrouped data. So for ungrouped data, so for instance, let me quickly show you how, let me give an example and let's find the mean, median, and mode. So if you have this set of data, you have 4, you have 8, you have 6, you have 5, you have 8, you have 9, you have 8, you have 7, you have 6. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think we have 9 values now. Okay, let's just use that. Should I add one more? That's okay. So if I want to find the mean of this guy, what do I do? So the mean is simply, so mean x bar, this is for ungrouped data by the way, is given as summation x divided by n. What is summation x? Summation x is the addition of every information that you have, and n is the number of everything that you have here. So in this place, you're going to add all of them. So I'm not going to rewrite it, so let me just add it from here. 4 plus 8 is 12. 12 plus 6 is 18. 18 plus 5 is 23. 23 plus 8 is 31. 31 plus 9 is 40. 40 plus 8 is 48. So 48 plus 7, that's 55. And 55 plus 6, that is 61. 61. You can always confirm that with your calculator. So you have 61. And then the n is, I think I should just add, let me add 2. Should I add 2? I have 61 already. I want to make it something that, so let me add another 9. Let me add another 9. Let me add another 9. Okay, let me just go to stop the data. So 61 divided by 9. So we have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 61 divided by 9. Let me press that on my calculator. Permit me. Hold on, please. That's approximately 6.8. Approximately 6.8. So the mean of this data is what? 6.8. Then we have the next one is to find the median. To find median in this case, all you have to do is that you have to rearrange either in ascending order or descending order. So you go, I think 4 is the least thing that we have there. So 4 is good, then followed by 5. How many of these 5 do we have here? I've only seen one so far. So 5 is good. 6. 6, 6. I think that's all. Then we go to 7. We have only one of it there. Then we go to 8. 8, 8, 8. 1, 2, 3. Then we have 9. So let's see if it is complete. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 of them now. So what you do is that you look for the middle point in this place. Now, of course, you can do that technically and you can do that using a particular formula, which I will give you very soon. So you have 9 of them here. I think if you cut it here, if you cut it here, see that, how many do you have here? 1, 2, 3, 4. How many do you have here? 1, 2, 3, 4. So indeed, this guy is our middle guy. So the midpoint is what? The median rather. The median is going to be 7. But it is easy to quickly determine this. All you have to do is that, just say n over 2, n plus 1 over 2 rather, if that is, if n is odd. So the position, to determine the position, just say n plus 1 over 2 if n is odd. But if n is even, it's a different case entirely. So you have to, I'm going to talk about even very soon. So let me finish this first. So if n is odd, you just say n plus 1 over what? Over 2. So in this case now, what is our n? N is 9. So we have 9 plus 1 divided by 2, which is 10 over 2, which is what? 5. So the fifth position is where you find the median. So you count this guy from the left or you count it from the right. 1, 2, 3, 4, 5. Or you say 1, 2, 3, 4, 5. You land there. But so, let's say, for instance, there's another guy here, 1, and then there are 10. So in this case, you actually say 10 over 2. You don't need to, it's just n over 2 for when it is even. But here's the case. If you count this from the left and right, you will not land on the same number. So you have 1, 2, 3, 4, 5. You land on 6 here. 1, 2, 3, 4, 5. You land on 7. So you have 6 and 7. So what you have to do is that you have to do 6 plus 7 divided by 2. And that will be 13 over 2, which is 6.5. So the median will then be what? Will then be 6.5 in that situation. So whenever you have data like that, you should be able to represent them properly. So that's that about that. We also have the other ones. So which is what? We have been able to find the mean, we have been able to find the median. So let's find the mode now. So for mode is simply the guy that appear most there. So you have 8, 8, 8 appear 3 times. 6 comes close, which is 2 times, but 8 is going to be the mode of that class because it appeared mostly there. And that is how you find mean, median, and what? And mode. Now, enough of ungrouped data. Let's talk about grouped data. So for grouped data, what we notice is that there's going to be introduction of frequency, like I've explained earlier. So I'm going to list out the formulas we're going to be using first, then I will explain how each of them works. The first one is our mean. Mean now is going to be given as summation fx divided by summation f. I'm going to explain all of these things. So what if you want to find the median? The median is simply LM. I'm going to explain what LM means in due time. So plus you have summation f divided by 2 minus f subscript b, then this divided by, so everything here over f subscript m, then you multiply that by c. So what does LM represent? LM simply represents the lower class boundary of the median class. I will also tell you how to find the median class, so don't worry about that. Then summation f, of course, sum of the total frequency, and then you have divided by 2, and you have minus FB. What does FB represent? FB represents the cumulative frequency before the median class. FB represents the cumulative frequency before the median class. That's why I'm using capital letter for this particular F. For this FM, like this, is the frequency of the median class itself. So you can say I use capital letter for one, I use small letter for one. So this F represents, some textbooks like to use CF. So I just want to use F to differentiate that. And C is the class size. C is the class size. For mode as well, for mode, it takes a similar formula as well. So you have L. I think I should use, since I've used M in this place, let me use N. Let me use N. So Ln plus, so you have this, you have, in parentheses, you have F1 minus F naught, F1 minus F naught divided by 2F1 minus F naught minus F2. Then all of these will be multiplied by C. All of these will be multiplied by C. So of course you should know what Ln represents like that. Ln will represent the lower class boundary for the modal class. F1 represents the frequency. So F1, it represents the frequency of this. F1 represents the frequency of the modal class itself. So F0 represents the frequency of the class before it. So the class before, all of this, when I'm solving a question now, you understand better. So F0 represents the frequency of the class before the modal class. F2 represents the frequency of the class after the modal class. And then this C represents the class size or class width, as you may like to call it. So let's quickly take an example and see how this works. So if I give you a set of data, let's say I give you this set of data, and I have I think I'll just give it in a table. I'll just give it in a table. So let's say we have the class intervals. So you have the max, then you have the frequency. You have the frequency. So just going to draw that here. So then let's look at the marks. So let's say you have mark from 1 to 10, you have from 11 to 20, you have from 21 to 30, and you have 31 to 40, you have 41 to 50. I think I should stop there. I don't want this video to get too long. And for frequency, let's say we have 3, we have 8, we have 14, we have 10, and let's say we have 5. So yes, we have all of this information. So what we want to get is that we want to get the mean, we want to get the median, and we want to get the mode for each of these data that has been given. So I'm going to apply all of this now, and you understand what is going on. So automatically it means that what I need to get here, because from this information you can see that I need the class boundary. So why don't I quickly get the class boundary first? So class boundary, let me extend this. So this will be 0.5 to 10.5, and I have 10.5 to 20.5. Then I have 20.5 to 30.5. No, yes, 20.5 to 30.5. And I have 30.5 to 40.5. Then I have 40.5 to 50.5. So I've gotten my class boundary like that. That's not straight enough. So the next thing we need there, we need our fx as well. So we need our fx. I think we need x first. So let's get x first. So that would just be the midpoint between these guys. You can be the midpoint here, you can be the midpoint here. So 0.5 plus 10.5, that is 11. 11 divided by 2, that's 5.5. That's 5.5. So I think you should also confirm all of these things with your calculator. I'm just trying to okay, that's 5.5. I've confirmed that with my calculator, so that's 5.5. So they will be increasing by 10 actually. So that will be 50. This one will be 15.5. This one will be 25.5. This one will be 35.5. This one will be 45.5. So we've gotten our x. So let's get fx like that. Actually, if I'm using Excel, this will be very, very easy for me. I will just compute everything like that. So let's get our fx. That will be 5.5 multiplied by 3. 5.5 multiplied by 3. Fx 5.5 multiplied by 3. That's 16.5. Then we have 8 times 15.5. 15.5 times 8. That is 124. 124. Then we have 14 times 25.5. That is 357. 357. Then we have 35 point. This one will be 355. This one will be 355. That's easy. Then we have 5 times 45.5. 5 times 45.5. That's 227.5. 227.5. So I think the last thing I need there is the cumulative frequency. So what is cumulative frequency? It's just basically we add in the subsequent frequency to get the next one. So this one, there's no frequency before, so it still remains 3. So it still remains 3 here. Now, but the moment we get here, that will be 3 plus 8. 3 plus 8 is 11. Now, where we stop here, we add it to the next frequency. 11 plus 14, that's 25. Yeah, let me confirm that. Yes, 25. So 25 plus 10, that is 35. And 35 plus 5 is 40. What you notice is that the last value of your cumulative frequency will actually be the summation of your frequency. So summation f will be 40 as well. And then, so what else do we need? So now we want to get the mean now. Sorry, the mean, yes, the mean, also known as the average. So for the mean is summation fx. Let me write that properly. So mean is summation fx divided by summation f. So you have to add all of these as well. Let me quickly add them. So you have 16.5 plus 124 plus 357 plus 355 plus 227.5. So all of that result into 1080. 1080. So the mean is going to be 1080 divided by summation f is 40. And so 1080 divided by 40, that's 27. So that's 27. That's 27. So we have the mean for the value now. So how do we now find the median? So the first thing is that we need to determine the median class. So the median class is going to be, so since we have 40 now, the median class is going to be 40 divided by 2. Just like I explained to you earlier, to find the median class, you just say n divided by 2. If you have odd, you say n plus 1 divided by 2. If you have even, you just say n divided by 2. So the median class will fall on, so instead of using n over 2 now, n is the total number of everything that I was given here earlier. But here I'm using summation f over 2 because summation f represents the total occurrence that I have in that data. So 40 over 2 is 20. So what you look for is that just go and look for where 20 will lie in your frequency, in your cumulative frequency. So this is 3, this is 11. 20 falls in this place. So 20 is not with 11. 20 is going to be in this 25 because this is where you reach 20 and this is where you also pass 20. So therefore, this particular class is going to be your, no, that's not what I wanted. It's going to be your median class. It's going to be your median class. So everything you need here will be supplied. So based on what we have here, I think I should just copy this out again. Yeah, let me just copy everything here out so that I can easily pick them. For my median, yes, I have this. I do not need, I've already applied that. So from here now, so you notice that I need, let's move that down a little bit. So for my median, I need the lower class boundary. I need the lower class boundary. That is your LM. So from the data, what is LM here is 20.5. So you have median. You have your median equals 20.5 plus, so from here we have summation f is 40 divided by 2 minus, what's the frequency of the cumulative frequency of the class before. So I've explained all of that already. The cumulative frequency of the class before, what is that? That is 11. So the cumulative frequency of the class before is 11. So you have 40 over 2 minus 11. Then everything divided by, so the next one is FM, which is the frequency of the median class. What is the frequency of the median class? That is 14. 14. And what is the class width? Class width is 30.5. This is 5 anyways. 30.5 minus 20.5, that is 10. So you have 10 here. So let's see that. That will be 20.5 plus. So this will be 20 minus 11. 20 minus 11, that should be 9, divided by 14. That is 0.64. So when you multiply that by 10, so you have approximately 6.43. 6.43. So 20.5 plus 6.43. So what's that going to be? 20.5 plus 6.43. That's 26.93. 26.93. So therefore, the median is going to be 26.93. Now let's do for the mode. So from here, the modal class will be the place where the frequency is highest. It's going to be the place where the frequency is highest. So in this place, luckily for us, our median class is also the modal class. So this place, because we have a frequency of 14 here, which is greater than every other person here. So what's the lower class boundary for the modal class? So mode. Let me write that properly. Mode equals 20.5 plus, so I've explained what F1 is for you earlier. F1 is the frequency of the modal class itself. I think we got that already. That's 14 minus F naught is the frequency of the class before it. That is 8. So we have 8 in that place. Then F2 is going to be 10 like that. So we have 8 and we have 10. So I just want to take note of the two of them before I proceed. So that would be 14 minus 8, then divided by 2 times 14 minus 8, then minus 10. Then everything multiplied by 6. The class width still remains 10. So you have 20.5 plus 14 minus 8 is 6. This will be 8, negative 18, then plus 28. So 28 minus 18, that should be 10 actually. So we have 10, 6 over 10. Then multiply by 10. So this 10 cancels. So you have 20 plus. So that will be 26.5. So that implies that the mode of this distribution is 26.5. So you can see that the mode is 26.5, the median is 26.93, and the mean is 27. You can see how close those values are. So that's why we call them measure of central tendency. They actually always, they always carry close range values like that. That is because they can perfectly represent the data that was given in this problem. And that's basically what you do with this information. Of course, there are still other things about statistics, but which I will not be able to discuss in this video because this is not supposed to be more than 30-minute class. It's not meant to teach you everything. So, but I think you have learned enough already, and you can apply what you have learned here to so many other things that you need to know as well. So we have range, we have, which is the difference between the highest minus the lowest value there. You have your quartile, you have your percentile. All of them, in fact, median is like 58th percentile. So median is like 58th percentile. So it's just application of this same thing. These are the basic fundamental things that you need to know. So that's it for that. I'll see you in the next one. Don't forget to like and subscribe to the channel as well. Bye.